Implicit differentiation. Find dy dx for the equation sign of x, y equals x squared plus y. We'll proceed step by step, and I will highlight each move as we go. Step 1. Differentiate both sides with respect to x. On the left, we write d by dx of sign of x, y equals. On the right, d by dx of x squared plus y. For the left side, we use the chain rule. The outer derivative of sine is cosine, and the inner derivative of x, y uses the product rule. That's x times d, y dx plus y. The right side is straightforward. The derivative of x squared is 2x, and the derivative of y is dy dx. Putting this together gives cosine of x, y times the quantity x d, y dx, plus y equals 2x plus d, y dx. Step 2. Expand and collect the dy dx terms. We distribute the cosine term to get x cosine of x, y times d, y dx, plus y cosine of x, y equals 2x plus d, y dx. Bring all dy dx terms to the left, and constants to the right. X cosine of x, y d, y dx minus d, y dx equals 2x minus y cosine of x, y. Now factor out dy dx. The bracket x cosine of x, y minus 1 times dy dx equals 2x minus y cosine of xy. Step 3. Solve for dy dx by dividing both sides by the bracket term. Dy dx equals the fraction 2x minus y times cosine of xy over x times cosine of xy minus 1. That is our result. Recap. Chain rule on sine of xy, product rule on xy, collect dy dx terms, factor, and divide. Every step shown gives a quick visual path to the answer.
Thank you for watching. Tap like, share, and comment, and then follow and subscribe for more quick problem-solving tips. Let's make maths simple. One video at a time, only on MyVerse Maths.